Now we need to calculate the forces at joint A. So step number one is we need to assume a direction for the forces AE and AC. So that will be a direction for a force. It will be assume this to be towards the joint, meaning compression. And for AC, we'll assume the direction is away from the joint, which is tension. Step number two is we need to resolve the forces that are inclined. In this case, we have AE to be the inclined force. So we'll resolve this into X and Y components. This will be the X component of it, and this will be the Y component of it. So I'll name them. This is AE, the X component, and this is AE, the Y component. So now let's update our sketch. So what do we have here? We have this force is known to us, this is unknown, this is unknown, and this is unknown. Of course, I'm not talking about this guy because this is already have been replaced by the two elements which are AEX and AEY. So now back to our equilibrium equation. We said an equilibrium equation for joint method of joints, we have only two equations available. That is sum of all forces in x direction equal to 0, and the sum of all forces in y direction equal to 0. These are the two equations available to us when we work with the joint method of analysis. Now the point here is that which one we should start with, and we always should start with the equation that will contain only one unknown. So let's try. Let's see if we will say sum of all forces in x direction equal to 0, what elements will be involved in this equation. So if we do all forces in x direction equal to 0, we will have this unknown involved. I will have this unknown involved. This is not the best situation that we would like to have. So let's try if we have let's try the sum of all forces in y direction equal to 0. If we will do sum of all forces in y direction equal to 0, we'll have this element which is unknown and this element which is known. That is all. So meaning that we have an equation in which we'll have only one unknown to work with. So that will be an ideal start for this solution. So we'll say the sum of all forces in y direction is equal to 0. Sum of all forces in y equal to 0 equation. So we'll have this element which is downwards, so it is minus AEY, and we have this element which is upwards, so plus 30 kilonewton is equal to 0. And then so 30 kilonewton is equal to AEY, and as we know, AEY is equal to AE multiplied by sine 45 degrees. So AE is equal to 30 kilonewton divided by sine 45 degrees, and that is equal to 42.42 kilonewton. So what does this mean? We got a positive answer for the force. It means that whatever we suggested for this force is correct, and the suggestion for this course was compression. So it means I should put in the front of this force that this is 42.42, and it is compression. So that is step number one. So we need to move to sum of all forces in x direction equal to 0. So sum of all forces in x direction equal to 0 equation will have this force is going west, which is negative, so it is minus AEX, and this force is going east, which is positive, so plus AC is equal to 0. and I can AC is equal to AEX, and AEX is equal to AE multiplied by cosine 45 degrees, and AE is calculated to be 42.42 multiplied by cosine 45 degrees, and that is equal to 30 kilonewton. And again, the answer is positive. And if you look at the direction of the force that we suggested is away from the joint, which means the force is 30 kilonewton, and it is tension. So we'll update our sketch to move to the next joint.